Before a single word is read on a page or a product is touched in a store, color has already sent a signal. It arrives at the brain's emotional centers faster than language, faster than logic, and often before the eye has even settled on a clear form. This is color psychology, the systematic study of how wavelengths influence human thought, feeling, and behavior at the intersection of perceptual science, biology, and anthropology. The mechanism relies on approximately 6 million cone cells concentrated in the center of the retina. These cells are specialized to respond to 3 distinct wavelength ranges: short, medium, and long, which we perceive as blue, green, and red. Because color is an immediate biological input, the visual system processes it as a direct stimulus. Every hue you encounter adjusts your internal state before you have formulated a single conscious thought about the object in front of you. Standard visual processing follows a predictable path. The signal travels from the retina along the optic nerve, through the thalamus, and into the primary visual cortex. However, the signal also takes a fast subcortical route bypassing the cortex, heading straight for the amygdala, the region central to emotional processing. This shortcut allows your emotional center to react to a color before the visual cortex has finished identifying what the object actually is. This biological mechanism is why the gut feeling from a color hits with such speed. It shapes perception, it influences mood, it bypasses awareness, all before you can consciously intervene. To understand how these signals work in the real world, researchers categorize color influence into 3 simultaneous layers: biology, culture, and personal experience. The biological layer is the most universal, involving measurable physical reactions. For example, blue-white light suppresses the secretion of melatonin, directly altering your circadian rhythm and biological alertness. The cultural layer relies on learned associations. In Europe, the historical scarcity and extreme cost of Tyrian purple dye created a social encoding that linked the color to royalty, an association that persists today even though the scarcity is gone. The final layer, personal experience, is the most unpredictable. Individual associations formed through lived experience, like a color linked to a childhood room or a specific event, can be powerful enough to override both biological priming and cultural trends. Since these 3 layers are always interacting, color psychology cannot be used as a precision formula for individuals. Instead, it is a tool for shifting population-level tendencies in branding, public design, and institutional environments. The impact of a color is dictated by its context, not just its wavelength. Take red. It is the most physiologically active color in the spectrum, acting as a priority signal to the nervous system. In competitive sports, this biological arousal can translate to perceptions of dominance. Athletes wearing red are often rated as more aggressive, and statistically win marginally more often. But look at a red fire exit sign. The context immediately transforms the meaning from aggression to directional safety. On a stop sign, the same hue is used to trigger a mild threat response that narrows attention and increases caution, helping drivers process a regulatory warning instantly. The hue provides the arousal, but the environment provides the decoder. Without context, the message of a color is incomplete. The assumption that color meanings are universal across all humans is one of the most significant errors in applied design. In many East Asian traditions, white is the color of mourning and grief, a sharp contrast to the Western association of white with purity or clinical sterility. Western cultures use black to signal the same state of mourning. These reactions are not anchored in our biology. They are social scripts we have to learn. We also cling to myths like Baker-Miller pink. While early reports suggested this specific shade reduced inmate aggression in prisons, more rigorous studies show the effect is likely a temporary reaction to a novel environment that disappears within days. Applying oversimplified rules found on mood boards often leads to communication failures. Real-world color success requires testing against specific audiences and specific goals. When applied intentionally, color can actually alter the wearer's performance. This is enclothed cognition. Wearing a white doctor's coat has been shown to improve performance on attention-related tasks, compared to wearing the exact same coat when described as a painter's smock. Functional design also solves for visual fatigue. Surgeons wear blue-green scrubs because the color provides a resting contrast to the red of human blood, preventing the persistent afterimages that would clutter their vision on white walls. In digital interfaces, the success of a buy button is driven more by visual scarcity than by the color itself. A red button on a gray page converts because it is a high-contrast outlier, not because red has a magical link to purchasing. Designers must also consider duration of exposure. High-saturation red is effective for a split-second first impression, but it becomes exhausting in a workspace where someone must remain productive for 8 hours. Intentional color use is about solving functional problems, guiding attention, reducing strain, or matching the expected visual grammar of a professional field. Color acts as an invisible, underlying architecture that regulates population-level mood, attention, and behavior. Question the color choices in the spaces you inhabit daily. The gray of an open-plan office or white of a hospital corridor are rarely neutral choices. They are most often the result of institutional priorities like cost or hygiene, regardless of their impact on your well-being. Understanding the science of color doesn't just make you more aware of design. It reveals a hidden layer of communication that is constantly adjusting the emotional temperature of the entire world around you.